Hey guys, Jacob here. So today I'm going to show you another puzzle that I made. This puzzle is different from the puzzles I've made in the past. So before I show it to you, I just want to explain to you the idea behind it. So I was looking at different three-dimensional solids trying to get ideas for puzzles to make. I saw this puzzle called the Rhombicuboctahedron, which is like a three-dimensional octagon, and I got the idea to make a cross cube shape mod out of it. So if you don't know what a cross cube is, imagine a 3x3, but an extra face is sticking out of each side, making like a three-dimensional plus shape, and each of those sides can turn independently along with the inner 3x3 part. So this puzzle, first of all, here it is. I am pretty zoomed out because this puzzle is quite large, as you can see, compared to my hands. Here's a 3x3 for comparison, so you can just see how just massive this puzzle is. The reason I made it so large was because of the mechanism I used. I'm actually gonna show you that right now. So the mechanism I decided to go with, as you can see, only has like 5 millimeters of space right there. So let's say if I were to scale it down to half the size that it is, then this would only be 2.5 millimeters, which is not enough. So yeah, I made it large so it would be stable and also improve the turning quality, which I believe that has worked. So the way this puzzle turns is you have an inner 3x3 part that turns like this. Along with that, you have these outer faces that turn, and these turn independently of each other, so you can do that and it won't really do anything. So the way you scramble this is you have to do a mixture of inner and outer turns. Like, for example, you can shift around the pieces on the outer layers with turns like this. So because of this, the outer part, these outer faces, solve very similarly to 5x5 centers. What I mean by that is, as you can see, you have a set of centers right here and a set of centers right here that turn independently of each other. We're ignoring the edges and corners for now. We're just looking at the centers. So as you can see, you can do mixtures of inner and outer layers to jumble around the centers on a 5x5. The same principle applies with this puzzle. As you can kind of see the similarity right there. So this puzzle, obviously it's massive, but as far as the size goes, it has an edge length of 60 millimeters, which means that the height from square face to square face when it's sitting on a table is 144.85 millimeters. I was able to figure that out by using geometry and math. In this case, knowing the relationship between the side length and the height of a regular octagon. In this case, since the edge length is 60 millimeters, the height of the octagon is 60 times the square root of 2 plus 60. And I don't really feel like explaining why that is, but that is true. So anyway, the main way you solve this puzzle is by solving this inner 3x3 frame. So like these corners right here, and then these inner edges. And then you solve the outer layers like that. So the solve is pretty similar to a cross cube. I would compare it to a normal cross cube, except I don't have one. So, we just have to work with what we got here. So now let's move on to the color scheme. So first of all, this puzzle has 26 faces, which means that if I wanted each side to be a different color, I would have needed 26 different colors of filament, which I don't even have half that. So the color scheme I decided to go with, for the square faces, I realized that there are 18 square faces, and so I decided to do 6 different colors for the squares and do 3 of each color. So there's 3 white sides, 3 yellow sides, etc. And the way I arranged them is I have white on one side, and on the other side you have white like off to the side with yellow between it, and then of course up here it's inverted. And yeah, so you can see you can just see the pattern of how they're arranged. And for the triangles, each triangle is a different color because there are 8 of them, and I did have 8 different colors. So for the triangles, I was originally gonna put one that didn't match any of the surrounding colors, but I can't do that because each triangle is surrounded by one of each of the 6 colors of the squares. So for 6 out of the 8 colors, there was no way for it not to match one of them, so I decided that touching diagonally is okay, but adjacent is not. So as you can see right here, I got white, but around it is red, yellow, and blue, none of which match the white, which is good. But as you can see, there is a white side touching it diagonally, but it is what it is. The only 2 colors that don't match the surrounding colors are purple and gray. That's only because there are no purple or gray squares. So I'm running out of things to say about this puzzle, so I'm just going to show you what the checkerboard pattern looks like. And what's interesting about this puzzle is, well, first of all, obviously the inside 3x3 part can be checkered easily, but when you do the outer turns, something rather fascinating happens. So look at the surrounding squares, the squares that are adjacent to the triangles. As you can see, the squares in the middle are fully checkered, but these squares are only half checkered. The reason for that is because for each middle square, one pair of opposite squares are the same color, and the other pair are different colors. Which means these 2 were the same, that's why it didn't change, but these 2 were different, and that's why it did. And of course, the triangles aren't checkered at all because of the way the puzzle turns. This blue came from over here, this purple came from this side, and this yellow came from this side. So yeah, that's gonna do it for this puzzle. I can't really think of anything else to really say. So, this is the physically largest puzzle I've ever made, and, my hands are getting tired of holding it because of how heavy it is. So, anyway, thanks for watching, and I'll see you in the next video.